good day to everybody. I guess that good afternoon to some of you. This is Harold speaking, also with the help of Giacomo and some other Intel colleagues. We have been working on these migration tools from OpenACC into OpenMP. So let's get started with that, and let's see if that responds. Okay. So I assume that most of you are already aware and know well the OpenMP and OpenACC directive-based programming languages, which are OpenMP and OpenACC, right? But just as a brief refresher, these are shared memory multi-core programming languages, or languages for to take the best of the computing infrastructure you have in your machines, in your computers, right? And they are not only using shared memory and multi-core these days, but they are also targeting heterogeneous computing. So the work that they leverage is not only on the main CPU, but you can leverage the work into some accelerators like GPU these days, or maybe FPGAs or any other, right? So OpenMP and OpenACC are both industry standards. We have several implementations created by some vendors. We have IBM implementations, for instance. We have Intel implementation, of course, but then we have some other institutions. We have research centers implementing different compilers and libraries on top of OpenMP and top of OpenACC. So industry knows very well these two programming models, right? And this is because I think that this is because it's quite easy to parallelize using these languages. It's easy because you basically can adopt the incremental parallelization of your code. Basically, you start adding pragmas into the code, or statements, or constructs into the code, and you can see how your application gets more and more benefit from the CPUs or from the GPUs, right? So these parallel programming languages are typically written on top of, or they rely on top of on C or C++ or Fortran codes, right? So these are the most common languages that are being used these days in HPC. I would say that Fortran is the most widely adopted, but we are seeing C and C++ being increasingly used in HPC. And OpenMP and OpenACC can be applied on this application, right? So OpenMP is currently in version 5.1. We are about to see 5.2, right? One of the things that we like from OpenMP is that this specification is not linked to a particular vendor, and it's not specifically linked to a particular accelerator type, right? So that means that you need support from whatever vendor or whatever accelerator, right? But it's not specifically focused on a vendor, and you are not located on that particular solution. One of the small caveats that OpenMP has with that aspect is that at runtime, all the accelerators have to be of the same kind, so you cannot mix, for instance, FPGAs and GPUs, or if you have different kinds of GPUs, you cannot mix them. I'm not sure if this has been addressed on 5.2, but if I remember correctly, that still applies, right? And as I said, for OpenMP, we have multiple vendors that are providing a compiler and library support. And we also have several open source platforms. And these open source platforms are based for instance, for the widespread GCC and Silang LLVM, but also from different research institutions, such as, for instance, BSc, possibly you have heard of OMS. So there's quite good promotion of the language, I would say. There are many groups pushing towards implementing the language specification, making it more robust and more wide in terms of accepting different kinds of constructs and different kinds of accelerators and the like. And this is something that someone would complain about, because the language has been increasingly more and more complex these days. And if you try to read the specification, sometimes it's a bit of a mess to try to identify what you want to find, right? So initially, OpenMP was focused on shared multiprocessors, and then later they started supporting accelerators, and that is something that we can clearly see from the status of the different compilers. Possibly the IBM compiler is the most mature at the moment for accelerators with NVIDIA, but we are working hard in order to get very good support in accelerators using OpenMP compiler in the Intel compiler. And I think that the support in accelerators have well, started very slowly, very steady at the very beginning, but now we are having a very good pace in the support of the accelerators. And yeah, possibly this is something that we will match with OpenACC version pretty soon. So for OpenACC, that was a solution that was developed for NVIDIA GPUs initially. They had very good support from some vendors like PGI and Cray, if I remember correctly. So they have been well, this language have been adopted by many HPC users for using on heterogeneous computing, and they did a good job, I have to say. The thing is that they are locked down into the NVIDIA GPU. So if you want to use OpenACC on other hardware other than NVIDIA, then well, you have to start doing some esoteric things like we'll see later, right? The other way around compared to OpenMP, OpenACC was, if I read correctly, was accelerator centric at the very beginning, and they added multi-core support later. So this is the reverse way around from OpenMP, and this leads to the one interesting question: for instance, what is the interoperability between the both languages, right? So one was focused initially on shared multiprocessors, the other one on accelerator centrics. Both are targeting the other direction, and at some point they should match. We have lots of software pieces here working. We have several applications, and we have reached a point in which we have several applications written in OpenMP. We have several applications written in OpenACC and different software pieces. And at some point, we also need to interact between the two, right? And that is something that it's not easy these days, right? Because you have lots of dependencies for one and the other. So since we have plenty of libraries, plenty of applications that we want to provide support on converting or moving from OpenACC into OpenMP, because that's the standard that we are supporting. We are working on a prototype for source-to-source tool translation that translates basically OpenACC applications into OpenMP. We initially planned this migration tool for Fortran, but later we extended it to support C and C++. And this is very simplistic migration tool at the moment. It's basically a Python-based script that parses the OpenACC pragmas and statements, and the script converts them into OpenMP pragmas and constructs and whatever it's needed. It's basically a line-to-line parser, so it's not using abstract syntax trees at the moment. There are no there is nothing fancy in the backend. But this is something that I'm considering to adopt if that's needed. But my main concern is on a good AST generator for Fortran languages, right? We have LLVM and Clang for C, but for Fortran the story is a bit different, right? So that means that the input for this migration tool is that we need syntactically and functionally correct input. So your application written in OpenACC needs to be correct. Otherwise, it's no one can guarantee the output of the code, right? The resulting code can be compiled.
Basically, we use for index, because the index is to represent these number right here of how we want for the VR gather to shuffle the data to the correct places. I
think someone is talking here right now without being muted.
Yeah, I think so. Thanks, Patrick. Yeah, okay. So the resulting code can be compiled with either OpenACC or OpenMP compiler. So if you're interested on getting one variant or the other, so that means that compilers can apply their own heuristics or optimizations for their specific or respective hardware or software libraries. And that also means that if you plan to keep using one or the other variant, you can easily adopt forthcoming specification extensions. So if there is something new in the specification you want to use, then you can basically take the translated code and basically extend it with whatever specification extension you have on the code. One of the things that I have to claim is that at the moment this is a prototype for translating applications from one language to the other. So the user has to visually inspect the translation correctness. At some point, we want to get something that is almost completely automatic, but it's a long road to get that status. So for the time being, so it's the user who has to double check for the result. So what are the OpenACC migration tools alternatives that we know? The first one that we knew was ACC to OMP, which was developed by Nicole Romero. That supported Fortran only applications, so more or less that supported what we needed for the starters. But we had some issues when translating some mini applications, so we decided to start from scratch, creating this translation. So other alternatives that we know, there is CLAC, which is developed by Oak Ridge, by RNL, right? So it allows you to well, it has two modes of invocation, or it has two modes of working. First one is traditional compilation, which translates these OpenACC constructs into an executable, and then the executable uses the OpenMP runtime underneath, and somehow there is the compiler who does the magic from converting these OpenACC statements or constructs and matching them into the OpenMP calls. The other alternative way of working is the source-to-source, which basically it gets translated OpenACC codes into OpenMP sources. And one of the issues that we have with CLAC is that it is focused for C languages. And we heard recently about FLAC, which is the same for Fortran, but we don't know what is the current status of FLAC, right? So for CLAC, we were able to find a place where to download it, but we don't know where is the current status for FLAC, and we don't know whether it is possible to download it and possibly work on top of it or collaborate with the works on developing FLAC. I don't know if someone in the audience would know about FLAC, but we would be delighted to learn more about this.
So this is Joel from Oak Ridge. I work on the CLAC project. Valentine Clement, who just went from Oak Ridge to NVIDIA, was working on the FLAC project. And one important point here may be that the FLAC does not do a translation from OpenACC to OpenMP. It just does a traditional compilation. And the status is that is being upstreamed as it's developed. I don't think it's ready for real applications yet, because just generally Flang is trying to get to the point where it's more robust for CodeGen. But I'm sure that they would be happy to work with you if you want to contribute to that project, and as would we if you want to contribute to CLAC.
Okay, thanks, Joel.
Sure.
So that's good to know. Possibly we can have a brief meeting with FLAC folks in order to discuss about that. So the latest addition into this list was shared with me this morning, and this is GPU4, which is developed by AMD. Competition is working with towards having this Fortran plus OpenACC and CUDA Fortran translated into Fortran plus OpenMP. I have been reading the requirements and the readments for installation notes and everything. And my understanding is that the GPU4 requires some additional OpenACC runtime component, which is based on GCC libgom and HIP++. So I'm not particularly sure that we want to take that road, right? So I would like to have some sort of solution that is agnostic to these kind of components which just stick to a particular compiler. But I have to claim that after a bit of investment or after exploring this or after working on this project, I can take the sense of what they are doing, so right. So they need to do some migrations or some translations from Fortran pointer to C pointers and the likes, and sometimes they would need that kind of library translation. So, but at the moment, our solution that we're proposing is basically source to source without any kind of additional libraries, and we'll try to stick to that as much as possible. So this is a very simplistic drawing of the migration process. So basically, we have an input file which is passed, or we have a number of input files which are passed to the Python script. Basically, what it generates 3 files from out of the input file. It generates a copy of the input file just for the sake of having a backup. Then basically we generate a translated file, so we can compare these two in order to see what has been added into the code. And then the tool also generates a report with some annotations for the translation of the file, right? So for instance, there are some nodes or there are some warnings regarding the kind of constructs that have been found in the code. So it can warn you whether there is something specific that you should check into the code. So the tool has a number of knobs. I would like to simplify this as much as possible, but these are what I have at the moment. There are a number of them which are the most interesting. I would, for instance, focus on the conditional defines, right? The first one here is with respect to prepend some, if defs conditionals into the emitted code. You can bypass that if you want, but you can specify a particular define if you want to protect your code, so that you can generate the 2 variants with certain defines. But you can also omit that, right? So if you are not interested on having any kind of if defs, and you know for sure that you're compiling with OpenACC compiler first or OpenMP compiler later, so each of the compilers will only take the respective pragmas or constructs, and they will do the correct work. Others which are interesting are, for instance, this loop, present, and async. These are knobs that help the tool to tell or to identify on how to work or how to deal with the translations of these respective loop, present, and async constructs. At the moment, when I started developing this tool, the OpenMP support that we had in Intel compilers was not that mature. The thing has been evolving, and this is why I added these knobs, because at the very beginning I was in the way of ignoring for instance, the loop constructs or moving them into collapse. But once we had the loop construct into the Intel compiler, then it was easy to basically keep the loop construct, right? And more or less the same happens for present, and something similar for async. I will cover them later, right, in the discussion I plan. So let's go over that. And now, if there are no questions, I would like to go with the demonstration I have planned. So if there are no questions, I will go for it. So let me move this here. Whoops. Okay, so I assume that you can see my terminal. Can someone say yes, please?
Yes.
Yes.
Thanks. Good. So I'm connecting to a machine that, oops, machine of mine, well, not a machine in our team. And I'm connecting to this machine, which has an Arctic Sound machine, an Arctic Sound device connected to that. And now what I will do is basically I will download the pod3d code, right? Now I will load the modules needed for the compiler. If I have module list and show the version for this and load the version, right? So basically, this is the environment that I had on this particular machine. The interesting bits here are the Intel compilers that I'm using, okay? And then the code is in pod3d and in the source code. And we have a number of Fortran files here. And now what I will do is I will translate them. Now what I will ask is to keep the loop statements, and I will ignore the async. And I will not use a conditional define because I don't want to mess with the Fortran preprocessor now. And that should be it. Okay. So that basically translated the code. If I compare the pod3d, the original version, and the pod3d with the translated version, right? What I have here is a comparison side by side of the two codes. You probably are aware about this bin-diff thing, which is pretty useful here. And we can see how the ACC constructs was converted into OpenMP constructs. Let me go to the other screen here, right? So we have ACC enter data copy in, which has been converted into OMP target enter data map. I can go down, for instance. These are target updates. Let me try to find here. We have an ACC parallel loop, and this is converted into OMP target teams distribute parallel do, and it keeps the collapse statement, right? It keeps the collapse clause here as well. Yeah, you can use bin-diff in order to do the comparison from one and the other, right? So that is pretty simplistic, I would say. So questions here? No? So it also generates.
We do have actually a question.
Oh yeah, go ahead.
So it says, and did you convert ACC kernels to OpenMP?
ACC kernels into OpenMP. That's a good question. So ACC kernels is something that the migration tool is not currently capable of converting fully, I would say.
Maybe we can discuss about that later.
Yeah, yeah. Okay, thanks.
Yeah, just to.
Yeah, I have a slide. I have a slide about that. So yeah, we will cover that later. But yeah, that's a bit cumbersome. So let's talk about that later. So let me go into the report that is generated, right? So we have in this file, we have a number of entries. Each of the entries refers to a particular statement or construct in OpenACC that has been converted or has not been converted into OpenMP, right? So for instance, we have here this translation ACC has been converted in ACC enter data copy in has been converted into OMP target enter data. Again, that's the same as we had before. But if we go down, for instance, we can have some. We see that there are some warnings on some entries. Here we have a reference to this warning, which says that which is respect to the async clause here that we have, and it's basically with respect that the OpenACC and OpenMP have different asynchronous mechanisms. So it's imperative that the user has to double check for the translation, right? In this particular case, I requested the translation tool not to ignore these async clauses, but I will show you later that we can more or less work with them. I don't know if there are others which are interesting. Yeah, ACC wait. In this case, this has been converted into nothing because the command line parameters and blah blah blah. Right. So this is what the tool generated, and now it's time for the user to modify the construct the building process. So let me modify the makefile. I have everything. Whoops. I have everything annotated here. So let me go over this. So here, basically, I'm tuning the Fortran compiler. And now I'm setting the Fortran flags, the compilation flags. So Fortran compiles it's IFX. For Fortran flags, we have FI OpenMP and F OpenMP targets SPIR64. So this ensures that you are lowering your tasking constructs into Asian hardware. Yeah, go ahead. Yeah, I thought there was a question on the line.
No,
Okay.
I think it was just a background noise.
Okay, no worries. Now for the link flags, I need to add the link flags HDI5 in addition to the HDI5. That's the only thing I have to add, right? So one can come here and one can compile it. Okay, and that generated the pod3d file. This is the binary file. And my plan now was to execute this, but there's a small performance hiccup on the Fortran compiler as of today. And if I want to run this, it will be extremely slow because one of reduction. I have already identified the issue. So one thing I need to do is I need to change the code. And this is not because of the translation, because of the performance issue that we have in the compiler. So we already reported the issue to the compiler folks, and they are working on that. I'm not sure if you'll. Oh, sorry, my fault. I I had to copy the translated file into the file, into the original file. No, this way. No, this one. Okay. Let me compile it again. Right. Okay, and now, as I was saying, we have this performance bug here that makes this execution quite long. So I need to go to the specific issue that we have in this particular. This is the reduction that we are having some performance issues. So for the sake of finishing the execution and keeping and keep going the discussion, what I will do is I will comment this out, right? And now what happens is I need to work with the data that there is on the host, right? So I will run this on the host, but the data on variables X and Y are on the GPU. Then what I need to do is I need to bring the data from the GPU into the host, and I can do that with the target update construct. So that's the only tiny change I have to do, and this is not related because of the tool, but because of the compilers of today, right? So let's compile it again. Good. And now it's time for giving it a try. So basically, we'll go into the test suite, validation, and input. And now what I will run is MPI run with two processes. So let me check what we have here. Yeah. So I will run MPI run, MP2, 3D. And this should finish. Doesn't take long. Okay, so this has finished, and this is the result that we had. The result is also stored in pod3dout. We can compare the pod3dout with the reference values that these are provided with the Git repo, right? Basically, we observe that the only differences are these white spaces here, right? So the numerics are exactly the same. So I would say that this has been successful on the conversion, right? So you may complain that possibly that this was not running on the GPU. So we can also enforce this one environment variable, but this is already set in our environment, right? So yeah, so this is basically the demo that I have planned. So questions on the demo?
I don't see any questions.
Okay. Good. This has also finished. So I had the steps here in the slide deck. I will share the slide deck with you folks so that you can play with that and you can see how I work with that. So one small note is with respect to the Fortran compiler. As you probably know, this is not production quality ready at the moment. Our Fortran compiler folks are working hard in order to get it into the best shape possible. I know that you are updated in a monthly basis. I think that then in the next monthly compiler, you would be able to get all this functionality running on your end, right? So let's continue from this point. So I would like to take the opportunity to have a discussion with you folks with respect to the translation. And I have a number of topics. And the first one was the ACC kernels that somebody raised the question on the chat box. For ACC kernels, okay, ACC kernels is more like a hint and not an assertion that the compiler has to do something. ACC kernel it's like telling the compiler, please try to extract whatever you can in terms of parallelism from this particular piece of code. And this is something that only the compiler can do, or in other words, it's the compiler responsible for doing the conversion, and the user is only responsible for suggesting on what to extract. These kernels not only applies on top of loops, but can apply on top of blocks, code blocks, like on the code here that we have. So the conversion of these ACC kernels is not straightforward for a source-to-source translation, right? So what we do on this front is basically what we do is we keep the lowering of this code into the GPU, but basically we convert that into the regular OMP target construct with no parallelism. And if you want to extract some parallelism, you have to, or the person who is using the script has to go there and has to explicitly mandate what is going to be parallelized, right? We're using regular Pragma OpenMP statements. So the only exception to that is if you have the ACC kernels loop where you are asserting that the subsequent statement is a loop. In that case, we can convert these ACC kernels into target teams distributed parallel 4 in this particular case. Otherwise, as I said, it's not practical or gets into this Pragma OMP target. This is not teams, should not be teams. It's only a Pragma OMP target, right? So I don't know if that addressed the question from the person in the chat. No.
Yeah, they said they
Okay.
did answer them. Yeah.
And just to add a little thing, the things are getting worse if we are considering Fortran and we are using yes, that's the point about the implicit arrays. Yes, I would like to talk briefly about that. So in Fortran, when you are using kernels together with implicit arrays, there's no way to convert it in them in OpenMP offload. I tried to talk with our Intel colleagues that are also in the OpenMP ARB in order to ask them if it would be possible to have the work share construct also to the target in order at that point to, exactly, in order to at that point have also the array syntax accelerated directly on the device. They are working on that, but we probably will not see it in 5.2 and even in, I don't know, if in 6.0.
We have a comment, I guess, from Jeff Hammond. He's asking or commenting that OpenMP target worksheet has been suggested but is always rejected because some people hate worksheet.
Yeah, I agree with you.
Yeah. Okay.
So yeah, I think that with implicit arrays, the thing is to go inside the code that translated by hand until we don't have something similar inside OpenMP on the devices.
Okay. Okay, let's move to the next topic I would like to discuss. It's with respect to the present clause, right? So Pragma CC has this present clause, which makes the runtime check whether the particular variable is already present on the GPU address space, and if not, it should raise an error complaining that the variable is not there. In OpenMP 5.1, there is something similar. There is a present clause, but this is not currently supported on Intel compilers yet. So this is the tentative that we could consider for converting that clause into OpenMP 5.1, but unfortunately we cannot give it a test, right? So I worked on providing different alternatives among that. The first one that is currently working is using the alloc clause. So basically the alloc clause on mapping on OpenMP, basically what it does is if the variable does not exist on the GPU memory address space, but basically it rather than failing and raising an error, basically it creates or allocates the variable into the GPU address space. It's not exactly the same as we had with the present. It's semantically different because it's not failing, but at the very end, it's giving more or less the same functionality, right? So this is the one I would suggest you to use the present alloc. There is another way of working with present, and it's specifying to from. So rather than allocating the variable, what you can do is you can specify that you want to update the variable on the GPU, and when the OpenMP construct has finished, then you update again on the CPU. Again, this is semantically different, and it is host centric. So that means that everything gets updated on the CPU at the very end. So it may have some problems if you have some other updates on the GPU and then your data is not synchronized between the two, right? So this to me is helpful for debugging purposes. So that can help, but possibly this is not the final solution that I would take. Also because it has a quite big performance overhead because you are transferring the variables every time. So you are transferring it to the device and you are getting it back from the device. So you are paying that performance penalty.
We have a quick question. Prison is supported in upstream LLVM. So I assume that means Intel will have it eventually. Is that correct?
Eventually we will have it. That is right. But as Giacomo points out, the IFX compiler uses a different backend. So we need to work on that. So for C, we may have some support, but from Fortran, that would be different.
Thank you.
So the other alternative that I've been considering, and this has been changing since I read the latest OpenMP 5.2 draft specification, is the device address. And honestly, this is making me nuts a bit because we have different device address clauses. We have has device address, use device address, and then we have is device pointer and has device pointer. And this is a bit of confusing to me. I personally think that this could be helpful if we cannot get keep, if we can have this before keep, but I possibly will deprecate this in favor of keep as soon as we have keep, right? And Giacomo recently shared with me his concerns about this default present, that we also saw that in the pod3d code. Basically, it refers that all variables referenced in the block of the code, it's present. It should apply the present clause. This is not currently supported in the translation tool, but there is a way in the OpenMP specific in OpenMP to specify that or support that. So there is this default map. So they should be quite easy to port into using the migration tool.
Yeah, at the moment, the default map present is not supported in our compilers.
You know if that is specific to Fortran or that also applies to C?
No, both.
Okay, what's up? Thanks, Jacobo. So the other thing, the other topic that there seems to be some sort of alignment between the two languages is the loop construct. Loop construct appeared in OpenMP 5.0, and basically you can convert this Pragma ACC loop into Pragma MP loop. This would work in OpenMP 5.0. I have no plans to discuss on how is the hardware mapping done here, because this is a bit obscure to me on how the competition does it, and I'm trying to understand better how do we do it. Because if we have a number of OMP loops within a word sharing construct, that means that we have to tell possibly the first word sharing construct that the hardware resources should be divided somehow, and I'm not clear on that, right? But at least in terms of the language, it's possible to have this kind of conversion, which is I would say more natural. And for performance purposes, we can double check that with the performance we obtained with Bitune, for instance, or with regular performance tools. For compilers supporting OpenMP 5.5 or older, there is some attempt into the code in order to convert the loop nest of Pragma ACC loops into collapse clauses. So, for example, here we have this Pragma ACC parallel loop and has a nested Pragma ACC loop, and that is converted into Pragma MP target blah 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 and a collapse of 2 levels, right? So that works on some cases, but fails when there are sibling nested loops because of the parsing. It does not have a very mature parsing of Fortran code, but for some cases it works. So if you are using all compilers or compilers having all OpenMP support, that is a thing that you can try. One additional thing I wanted to mention is that in OpenACC, the loop construct, you can specify the number of gangs, the number of workers, and the vector size. And these are the number of teams, the number of threads, and the vector size in OpenMP jargon. You can specify that in OpenACC loop constructs, but this is not available in OpenMP loop though, right? So for the time being, this is being ignored on the loop construct. Good. Yeah, questions before I move on?
I think there was one that Gaico already answered, and then there is another one. It says, are there any cases that cannot be translated line by line?
Cases. Well,
Or the kernels, for instance. So I don't know if
yeah, the kernels.
what you mean with line by line, but
yeah, line by line translation. If he refers to having only when you are parsing the code or when you are exploring the code, if you only have that line of context, one line of context is not sufficient for many things like the kernels construct, as Giacomo suggested, but also in these loop constructs, right? So because you also have to understand the language and understand whether that is a loop construct, or excuse me, that is a loop, or that is a if conditional, or that is a whatever, right? So that is. So let me move on. So with respect to
sorry, there is a question about the auto close. If we are translating that, if I remember correctly, not yet.
Not yet. We are ignoring that at the moment. So the next topic I had here to discuss is with respect to the asynchronous, and OpenACC async clauses are different from OpenMP asynchronous. In OpenMP, we have two different or big different ways of doing asynchronous, right? First one is the use of the no wait, which could be helpful to mimic the OpenACC behavior on simplistic cases like the one we have here, and I will show you later. And then for more harder or more esoteric cases where we want to express different where we want to express change of dependencies in using async, we can use, for instance, the depend clause, right? And this is because the async clause on OpenACC, it receives a number, and that number is the identifier for the string that where you want to submit that specific job. And that means that you not only have one stream of work, but you have multiple streams of work running there, and you have to synchronize them well, right? So for the case that we had on pod 3D, for instance, in the case that I ignored the async clause, for instance, this is a portion of the code, and the OpenACC constructs had the async, and at the very end they had the ACC wait, right? And note here that this is what it's doing. It's submitting these three pieces of work independently to the three different streams. And in that particular case, I decided to ignore the async clause because there was at some point that the Intel compiler didn't have full support of the no wait clause. That is already in the compiler. So one alternative that we could try on that is converting the async into no waits, right? So rather than sending the three different loops into three different streams, we would send them into the same queue, but this would be done asynchronously, right? And that also implies that at the very end, we also have to convert this ACC wait into OMP task wait in order to wait for this to synchronize with these three executions. So questions or comments on the asynchronous? Not, I'll move to the non-contiguous data mapping. This is something I found when translating a customer code written in C++, right? It was interesting to me to see that OpenACC supports data mapping of these non-contiguous arrays. That is basically when you have on C, where you have pointers to pointers, where you have one malloc that allocates the space for a number of pointers, and then basically you create a table with those pointers and creating and allocating for each of those pointers, excuse me, for each of these positions and a new pointer, right? So that is supported in OpenACC. I was trying that in our compiler, and that was not directly supported in our compiler. I had a discussion with our compiler folks, and they claimed that what was the performance cost of doing that or supporting that. And what they told me is that OpenMP 5.0 has these iterators defined that should help or are meant to help on this front. But unfortunately, this is not implemented on the Intel compiler yet. But the plan would be to take advantage of those in order to convert this example here, right? So here, this is the offending line that I had, right? So we had this Pragma ACC enter data copying filter, and this is 2-dimensional data. And basically, this is what the translation tool generated. So basically, it's the same thing. It's OMP target enter data map, and basically the same variable with the 2 dimensions. But at this point, the tool does not know whether this is contiguous or not contiguous array. So what it does is it proposes an alternative code or implementation code for that thing, for that particular piece of code. And that particular alternative implementation it's like that. So first we allocate the first dimension of the variable, and then for the remaining dimensions, and that is only 1 dimension in this case, but for the remaining dimensions, basically we copy the data from the CPU environment to the GPU environment using the different indexes, right? So basically we have in this case 1 allocation, and then we have a loop of a number of, in this case, the loop tree count is the number of, it's the size, and where we do the transfer. And that is what I believe that OpenACC is doing under the hood. What else do we have? Things that I noticed when doing this tool is the Secluse. Secluse, it's a mechanism that OpenACC allows the user to indicate that either a loop or a routine can be executed sequentially, and there should be no parallelization, no vectorization on the code, and that means to be executed like it is. And I was looking into the OpenMP spec, and I was not able to find anything similar. I had a discussion with our folks, and we didn't have any particular suggestion for that. Currently, the Secluse is being ignored, so we have to take it with a pinch of salt. Our gut reaction is that there should not be a Pragma, OpenMP Pragma or OpenMP construct for that, but we're still working on that front.
We have I
Yep.
guess a question and a discussion. So the question was, what is the advantage of using OpenACC?
What is the advantage of using OpenACC? Okay, OpenACC was developed by NVIDIA and has other companies supporting that language. Initially, OpenACC was targeted for, well, it's currently targeted only for NVIDIA hardware. NVIDIA had GPUs before than the competition, and there were a number of adopters of that language. So I would say that the advantage of OpenACC was that at that moment they were able to parallelize or to take advantage of the accelerator in an easy manner by simply adding these pragmas into the code. And since they were the only ones there, so they were the ones that could take advantage of that. Nowadays, we have in OpenMP, we have the target construct, and we have a number of vendors who are supporting that. We have IBM, we have, well, we have ourselves, we have Intel, we have AMD is also working on that. We have a number of open source codes, compilers, excuse me. So I think that that it's important is that we should be able to take advantage of the GPUs on either GPU hardware, either accelerator that we can do, and that is not using OpenACC at the moment.
There was a discussion about the compiler choice, and then the questions are why not ACC routine sequential to OpenMP declare target? Okay, so ACC routine.
Sorry, Harald, I already tried to reply to this. So this is something that we are talking about, but the problem is that there is nothing in OpenMP concerning the sequential clause.
Yeah, the sequential clause is the problematic. For ACC routine, we currently convert it to OMP declare target. that is done. But the concern is with the sec clause.
And to be honest, this is probably because I don't know so much in deep OpenACC, but sometimes I don't understand why the sec clause is needed in the loops, because it seems to me that, at least from OpenMP point of view, if you put some parallelization directive in the outer loop, then and without any collapse clause, then the inner loop is not automatically parallelized. So you don't need any pragma that prevents the parallelization there. Well, in OpenACC, it seems that the ACC, for instance, the ACC loop sec is needed. So yeah, this is another thing about the sec clause.
Good. So time is almost up. I don't know. We have 5 more minutes to finish the presentation.
Yeah, you can finish 5 more minutes. That's fine.
Okay. So next topic I had in mind was performance portability. Both OpenACC and OpenMP have 3 levels of parallelism to be set. On OpenACC, we have gangs, workers, and vectors, and on Teams we have teams, threads, and vectors. So it's basically the same with different names, to be honest. But it's not the same as the hardware, right? So one thing that I have been discussing with some folks at Intel is, okay, we can have an OpenACC construct which has this specification, or where the user requests a number of gangs or a number of workers, just for a simplistic case, right? And what does it mean when we port it to an Intel GPU or when we port it to an AMD GPU? Does it make sense to have the same numbers here? So these numbers here, for instance, NG and NW, this is typically very hardware specific, right? So the tool can port it. There is no problem in porting them, but honestly, I would suggest to take a look at some performance analysis tools in order to ensure that the performance of this is the one that you would expect. Let me go to the next one. The last topic I had in mind when working on this, and I need to invest more time on this, is the interoperability with the runtimes and with the backends, I would say. So in OpenACC, the API has some interaction support with the CUDA runtime or the OpenCL runtime. So for instance, we have this ACC get current CUDA device or context. There was some additions in OpenMP 5.0 which includes the interop constructs. So you can interact with the backends, and we have a couple of examples. One is from Marcon, which is this OpenMP and SQL interaction, and we also have some examples in the OpenMP specification examples directory with OpenMP and CUDA interaction. So this is possible, but what I wonder is whether the applications are using these features these days. So is OpenACC not sufficient to cover the needs of developers? Do they need to go to this level in order to get additional support from CUDA in this case? I don't know. So what's your feeling on this? So any developer, application developer here who's developing in OpenACC is using this kind of routines? No?
Sorry, for me, this kind of API, it's a nightmare. Because if you use something to speak with CUDA or with cycle, it means that it's no more portability. So for me, you will use only NVIDIA cards. So it's again the goal of usage of OpenMP or OpenACC. So I never want to use this kind of things. I try to do every time to go without this kind of things, because I want to be able to go from one hardware to another one. So if I use a CUDA a special CUDA API, it means that I will not use only CUDA, so it will be not more portable. So it's my point of view.
Mm-hmm. Yeah, I get your point, and I think that I'm happy to listen to that, because that's what I believe as well, right? So OpenMP and possibly OpenACC should be relatively, if not completely, portable, and using this kind of interop things or interaction things with the backend runtime. Okay, that could be good, but that possibly means that the specification, whichever of the two, needs to be matured a bit more, right? So possibly it needs something else in order to express something that it needs this interoperability thing.
So for me, it's the same, that you want performance, the high level of performance, you use CUDA, you write for your hardware, and that's all. If you want portability, you accept. Mm-hmm. You don't accept to use this kind of API.
Okay, good. Thanks. Any other one in the audience that would like to share some thoughts? Okay, if not, I will go to the conclusions and our future work, right? So basically, we've shown the prototype tool that we are working on, helping migrating Fortran and C and C++ OpenACC codes into OpenMP. We know that this is a prototype and we need to invest more time into that. We have the perception that we are on the good track, even though that the way of working with that, not using AST parsers, for instance, is kind of limiting the kind of applications that we can support. But our interest on presenting the work here today is basically on gathering feedback from you folks in order to understand how are you using OpenACC, what is your expectations, and what is the things that you need in order to support at the very end more complex applications. And basically, that would mean to extend the support for other OpenACC constructs and other applications that you have and the like, right? So as I said, abstract syntax tree would help on parsing and on digesting the code, the original code. We have good AST parser generators for C, but we gave a try to different AST generators for Fortran, and I was not happy with the result. So I would like to have the support for both languages, C and Fortran, to be at the same level. But yeah, I need to explore what is your request on that front. Whether you're interested on Fortran applications only, whether you want also to support C applications. So that would be very good for us to understand, in order to know where to invest the cycles. And well, basically, because it's my background on performance suggestions and evaluations, I would like to provide some sort of guidance whenever possible, right? So on OpenACC, we had these gangs and workers and blah, blah, blah. On OpenMP, we have something similar on teams and threads. I would like to give some perf hints. I completely understand that this is basically very tied to the hardware. And as our previous speaker was mentioning, this is possibly very tied to a particular hardware. And that's possibly that I think that we don't want to be tied, but I at least personally, I would be interested on learning on those. And the other thing that I'm interested is also in performance. But in this case is to evaluate how the OpenACC and the translated version, how do they work? How do they compare in terms of performance? What is the performance that I achieve when I use different compilers and hardware? For instance, if I take the OpenACC code and I translate it to OpenMP, how it behaves if I compile it with the NVIDIA compiler? What is the performance that if I use the Ceylon compiler on NVIDIA hardware? Or for instance, what is the behavior on OpenMP using Intel compiler, right? So this is something I also have in my mind to work on. But this is possibly a bit out of the context of the conversion or the migration itself, but still these are interesting points. Right? And that is all from my side. I don't know I've seen lots of messages in the chat box. I don't know if.
Yes, Harald, just one
Yeah.
question. If you want to say something about the release of the tool, so if you want to release it, how you want to release.
Okay.
At the moment,
That's a good
public,
point.
right?
That's a good point. So for the time being, this is not public. I think that we could share it with the folks having an NDA. But the main idea is to make it public when I have some time. As of now, I'm on paternity leave, and I will be back by mid-November. And I assume that the open sourcing will take some amount of time. So I cannot put a time frame, but this would be one of the on the top of my pile of things to do when I'm back from paternity leave. So possibly end of this year, early next year. I don't know. I don't know if I could promise that date, but this is the one of the first things I will do when I'm back. And for those of you who have an NDA with us, possibly we can have a chat. Possibly we can ping Jean-Nim or Giacomo to discuss on this topic. Possibly we can give you a first shot of this with you.
Well, thank you so much, Harold. I see there's a discussion
Sorry,
going on in the chat.
I have just one long question for all the audience. So if they want to share with us, possibly yes, via mail, all the OpenACC constructs that they need, absolutely. So if they already ported their code to OpenACC, they already optimized their code with OpenACC. And so if there is any OpenACC construct that they cannot live without, so we can check if the RLS tool already converts these pragmas, and if there is, if not, if we can convert them, and if not, if there is anything else that we can do with OpenMP. This will be a good help for us.